Hello everyone and welcome to another tutorial. I will hopefully start to go over my new project, which is the fractions project. So currently let's just close all that so I can focus on fractions. So make a new file, call it fraction or whatever you want to call it, that lets you know that you're working on fractions. So let's open this up. So the first thing that I made when I've been working on this for a little bit was a double, because this number is what's going to be evaluated and will give us back the fractions. So double number equals whatever number you want. Now this is the new thing, math context. So what math context does is it allows you to add precision and also lets you do some other things. So let's see some of the properties that has. MC dot equals get precision. So precision is basically like, let's say you have 1.231, let's say that precision is, I believe, 4 or 3, but we can check that right now. So system dot out, don't worry, I'll go over what this does right after I show you what precision does. So MD dot precision dot get precision. There we go. So if we print this out, fraction running, it prints out 4. The reason is because it has 4 lines of 4 numbers of precision. 1.231, and usually if you do string dot value of number dot length. Okay, so this is what happens. So if you run this, you'll see that you now have 5, because for some reason it adds an extra 0 at the end of it. I don't know why that happens, but it just does. So what math context does is it allows you to set the number of the precision of the number that you're trying to subtract, you're trying to add, whatnot. So how you call this is math context, and you do need to import it. So at the top, import BigDecimal and import java.math.mathContext. So once you have finished that, you're going to do math context and then make a variable, wherever you want to call it, equals new math context, and here's the precision, the amount of precision you want. So what I did was I changed the number that I got into a string. So I did string dot value of dot length, because integer or double does not have a length function, and also number does not have any any methods to go with this, just a variable. So what I had to do was I had to change the number into a string and then call the length of the string. So that gave us 5. So I subtracted it by 1 to give us 4, the actual number, 1.231. So even if I add zeros behind it, I will still get 4, because it doesn't count the zeros in it. It only counts like leading zeros. Like if I put a 0 up here, it won't do anything. It will just consider the numbers that are only non-zeros. Now if you put a 0 here, it will obviously count it, because it's 1 2 3 0 1. So if I do that, you'll see 5, 0.2301. So the next thing we're gonna do is BigDecimal. Now what BigDecimal is, it allows you to do certain things with decimals. It allows you to be able to add decimals, subtract decimals with precision that you want it to have. So for some reason, when like doubles and floats do not give you have like rounding problems. So if you're trying to subtract 2 doubles, you're gonna get either the correct answer, or you're gonna get some weird crazy answer. that's close to it. Technically, it's the correct answer. It's just the amount of precision is unnormal. It's like 512 levels of precision. Yes, that's good, but that after a while, that could take if you do a lot of that kind of math with that kind of precision, it's going to have issues. It's going to take up a lot of memory, and it's going to just take a while. So with this big number, big decimal number equals new big decimal, the number you're assigning to it, because you have to assign it a number. You can't just do big decimal like a normal thing, like a normal constructor. How we did with character, which we could just put a character and it could do it automatically for us. Um, you do need to add parameters. So in here, you're going to give it a number that you want it to be changed into a big decimal, and then the number of the precision of that number, or the precision of the big decimal. Once you have that, this is just me testing MathContext out. I made another big decimal, other equals new big decimal, and I just assigned it 1. You don't have to assign it a variable. You can just assign it a straight number. And then this is where some people get a bit confused. Uh, Normally, you think number minus other will give you some number. Well, the thing is, you can't subtract big decimals like that, because big decimal is an object. It's an entire class. You can't subtract one class from another. But you can do this. Number dot subtract, and in the parameter is the parameter of that other big decimal. It gets the variable, because I'm going to assume that the method is like this. So this is just this is how you write a comment: forward slash, or you can do forward slash star. Let's just call that star, and then press enter, and you see how it create another one. So this is how I'm going to think that big decimal is. So you have your public class big decimal, right? You have your constructor, right? Let's just put constructor, and then you have the method public. It's going to return a number, right? So double, and then subtract, and then it takes the variable of big decimal, right? And then what it's going to do is it's going to get this variable that has the number that was assigned, this number, or actually it's going to return, because it's returning, if you remember, double means it's going to return a double, void means it's not going to return anything, string is going to return a string, like that. So this number, right, let's just call it whatever, let's say big decimal, it's holding the variable of what you assigned it, right? So let's just call it number, subtracted by the big decimal variable that was assigned, minus variable dot whatever number it was assigned, and it returns some number. So as you can see, number 1.2301 subtracted by this number will give you 0.2301 with that level of precision. Because the thing is, let's say you want just solid numbers, you don't want an infinite number of zeros or nines behind it, because with double, if you do 1.2 minus 1, you get 0.19999 whatever, or 0.2 with 512 numbers of precision, levels of precision. So you get like 512 trailing zeros, and that's really annoying when you see it. You'll be wondering, why isn't it just giving me 0.2? I mean, it's an exact number, isn't it? Yes, but doubles have issues with rounding. So that's why I saw on a post that people who do banking, they use levels of precision, because then you can get errors with monetary value, and you need that level of precision when you're using monetary values. Monetary, if you don't know, is things to do with money. So precision is really important. So now that we're done this, right? Now that we have the decimal part of the variable, right? Now we're going to go over how, now that we've subtracted out the number from the number from the decimal from the whole number, right? Now we're going to do this. We're going to say int, let's say digit equals, now we're going to assign this, we're going to do this, we're going to say, we don't need this, that was just an example. We're going to make num double, actually we're going to need that, big decimal, let's do temp digit is equal to new big decimal, and we're going to make it an int num. Now what that's going to do is it's going to change this number into an integer, so just give us 1, hopefully. And then what we're going to do is number 1.231 digit is actually going to be temp digit dot int value. And now if we print out digit, let's say what this is, digit was, and if we run this, we should get, yep, 1. Digit was 1. Because with integers, it doesn't round. So if you have 5 or 6 or 7, as you show, it should just give us 1. It just gives us the first integer. It doesn't round up or round down. Now you could, with math context, you could allow it to round up or round down depending on how you want it to do it. But we don't want any rounding because that will give us some issues. Like 1.5, you don't want it to be 2 because when we convert to 0.5, you're gonna get 1/2, so it'll be 2.5, which is wrong. It should be 1.5. So now that we have that, right? Now we're going to go and assign the fraction part, right, that we want to get. Fraction equals number dot subtract, like we did before, and we're going to subtract by temp digit, by temp digit, because you have to subtract, you can't subtract numbers, you can't subtract integers or doubles. You're subtracting, as you see here, a big decimal by another big decimal. And so when this gives out this returns a big double, so dot, and we're going to give 2 big integer. Let's see if we can see if any of these returns a double value. Here we go. And let's just make sure that this gives us what we want. So system.out.print line, and let's just do a fraction. Now I'll probably not want to use fraction double, because then I'm probably gonna get even more errors later on. But that's just to show you how you can change, how some methods have the ability to change their class and give out double value. So that's what big decimal is good for, because it can return ints, long, short, and strings. So now that we have that, now that we have our fraction, we need to figure out how big the number is. So let's say you have 0.5, right? So that's 1/2, but how did we get to there? Because we did 0.5, we multiplied it by 10, right? So it's 0.5 over 1, right? So let's, why is that on there? We did 0.5 I actually don't know. Oh wow, we're at 15 minutes. Wow, this is a long tutorial. So I'll just wrap this up real quick. We did 0.5, we multiplied it by 10, and we got 5 divided by 10. Now we simplified it, so we got what the biggest number it could go, what number can go into 5 and 10. What's the biggest number? And it can be 1, but we can also do 5. So we did 5 divided by 5, we got 1, and we got 10 divided by 5, which we got 2, and that's the smallest number that we could get. And that's how you get your fractions. Now you have 1.1 and if you want to do an improper fraction, which is where it's not simplified, right? So it'd be 1.5. It's 3 and over 3 over 2. 2 times 1 is 2 plus 1, and you get 3 over 2. So that's pretty much what we're going to be doing in the next tutorial. We're going to be getting this value and getting the length of it and multiplying it by 10, and then going through what numbers can go into that, what's the biggest number that can go into that evenly. So thanks for watching. Subscribe, like, share, and comment. Have a great one.